Algebra 2, Unit 6, Lesson 2, and in this lesson we're going to learn about the square root property. In order for the square root property to work, you have to have a perfect square trinomial. So first I want to explain to you what that means. A perfect square trinomial is a trinomial that can be factored into two of the same factors. This will only happen when the number here is square, and the square root of that number, if you take the square root of 25, that's 5. If you multiply that square root by 2, it will give you the middle number, and you'll know it's a perfect square. So the square root of 25 is 5. 5 times 2 is 10. If you have that pattern in a square trinomial like this, then you know it's going to be a perfect square. So if I were to factor that, I would say, what factors of 25 add to give you 10? Well, that's 5 and 5. And that is a perfect square trinomial. This plus tells me the signs are the same as this, so they're the same sign. And since that is a perfect square, and we end up with the square root times 2 for the middle term, we know these are going to be perfect squares. So basically what that is when I factor is x plus 5 squared. So that's what you need to understand first when we're doing this section, how to recognize a perfect square trinomial. So in this one, the square root of 16 is 4. 2 times 4 is 8, so we know this is a perfect square. This always has to be a plus if it's a perfect square, because the plus tells me the signs in my binomials will be the same. In order for it to be a perfect square, the signs have to be the same in each binomial. 9 is a square number. The square root of 9 is 3, and 3 times 2 is 6, so this is also a perfect square. So we have to recognize perfect squares before we can do the square root method. So I'm going to give you a couple minutes. Pause the video, write down the method for solving using the square root method, and then I'll come back and we'll do some examples. Okay, notice on this perfect square trinomial, I have set it equal to 49 so that it looks like one of the problems that we will have in our work to do tonight. The method for solving using the square root property. You're going to factor the perfect square trinomial, so you're going to factor the left-hand side. Now, normally, I've told you before, we're not allowed to factor the trinomial until we get the trinomial equal to 0, or we get one side equal to 0, then we can find the roots. This is an exception to the rule. If we have a perfect square trinomial, there's another method for solving these. In order to do this method, you have to start with a perfect square here. So you're going to factor the perfect square trinomial. You're going to take the square root of both sides. Now remember, when we put in the square root, we have to make sure we put a plus minus in front of our answer. So that's going to be something that you have to make sure you do. 3, you're going to set up 2 equations. And then 4, you're going to solve the equations and simplify your answers. So let's just go ahead and do this. First thing we do is to factor the perfect square trinomial. So we know this is perfect square because of the pattern. This is a perfect square number. The square root of that number is 5, and 5 times 2 is 10. So we know it's a perfect square because it fits that pattern. And I'm just going to factor. Factors of 25 that add to give me 10. Well, we've done this already today. That's 5 and 5. So we've got x plus 5 and x plus 5, and that equals 49. Now, that means this is x plus 5 squared. So that's what we've got. Now, in order to get rid of the square, I'm going to take the square root on both sides. If I do anything to one side, I have to do it on the other side as well. So I've put in a square root to solve this. So on this side, I'll have x plus 5, and on this side, I have to account for the positive and the negative that could give me a 49. So I have a plus and minus 7 on that side. So 2 possible answers. Remember, when we have a polynomial equation, whatever the degree or the power, the highest power of that polynomial is how many solutions I will have. So I have to put the plus minus in there to account for both of the answers. And then what I'm going to do is I'm going to set up 2 equations. So I have 2 equations. X plus 5 equals positive 7, and x plus 5 equals negative 7. By setting up these 2 equations, I will get both of the answers that will be solutions to this equation. And so I've got x equals 7 minus 5 is 2. And on this side, x equals negative 7 minus 5 is negative 12. So my 2 answers are 2 and negative 12. That means those are the 2 points on the x-axis where our parabola will cross. Now, this was a positive number, positive a, so we know it's the graph will be going up, and it crosses the x-axis at 2 and 12. In this one, let's look and see if this is a perfect square trinomial. The square root of 9 is 3, and 2 times 3 is 6. So that is a perfect square. We can factor it. That's x minus 3 times x minus 3, which we know is x minus 3 squared, equals 32. Now, it is fine if you want to go straight from here to here. If you're capable of doing that without any work, I'm okay with that. Just make sure you're getting this right every time. If you don't get that right, your answers will all turn out to be wrong, so you want to be really careful with that. Next step, I'm going to take the square root of both sides. When I take the square root, this side is just going to be my x minus 3. This side, I have to include the plus minus. And 32 is 16 times 2, so I can bring out a 4, and I'll have the square root of 2 left inside. Well, this did not turn out to be a nice whole number, but that's still okay. We just have some irrational roots to this one. We're still going to have 2 of them because of the plus minus, but this time they're not nice whole numbers, they're going to be irrational roots. To solve this, all I have to do is add the 3 to the other side. So x equals 3 plus or minus 4 times the square root of 2. So your two answers are 3 plus 4 square root of 2 and 3 minus 4 square root of 2. And this one, now this one's a little bit different. I have a 25 here and I have a 9 here. 25 times 9 is 225. 225 is a perfect square. 15 times 15 is 225. So we know that 25 times 9 is 225. What numbers or what factors of 225 add to give you 30? Well, that's 15 and 15. So when I factor this one, well, the square root of 25 is 5. So we have 5x. The square root of 9 is 3. Those are going to be the numbers we put in our binomial. The plus tells me that the signs are the same and they're both minus. So you can check this. That's negative 15 minus 15 would give me the negative 30 that I'm looking for. So perfect square still, even though this is something other than 1, if both of these are perfect squares, it will work. So we have that equals 96. So this is 5x minus 3 squared equals 96. I'm going to take the square root of both sides. When I do that, the left-hand side is 5x minus 3. The right-hand side is plus or minus. Now, 96. I know that is 3 times 32. And then 32 is 2 times 4 times 4. So I can bring a 4 out. So that'll be a 4 square root of 6 left inside. Then to finish this one, I have to get x by itself. So in order to do this, I do not have to set up 2 separate equations here. I know that I have a plus minus. I know it's going to be an irrational number, but that's okay. I'm just going to solve this for x like I normally would if that was just one number over here. So I'm going to add 3 to the other side. So I have 5x equals 3 plus or minus 4 square root of 6. And then I'm going to divide both sides by 5. So x equals 3 plus or minus 4 square root of 6 all over 5. And this would be my answer. I do have 2 roots here. I have 3 plus 4 square root of 6 over 5, and I have 3 minus 4 square root of 6 over 5. Those are my 2 roots. So I do have 2 roots because it's a square. I know the power is 2. I have to have 2 roots, and I do. Okay, here's another one. I'm going to factor the perfect square first. So if I do that, 9 times 1 is 9. Factors of 9 that add to give me 6 would be 3x, or 3 and 3. So I've got 3x and 3x. I've got a 1 and a 1, and we know the signs are both pluses. And that equals negative 16. Now, this one's a little bit different because when we take the square root, I know I have 3x plus 1 squared equals negative 16. When I take the square root of both sides, this side is just 3x plus 1, but this side, notice there's a negative underneath. Well, we know how to deal with negatives now. When we have a negative under a square root, we're going to bring an I out. So this one is plus or minus 4i. So we know that's plus or minus 4i. To solve this, then I just need to get x by itself. So I have, if I subtract the 1 over, 3x equals negative 1 plus or minus 4i. And then if I divide by 3, x equals negative 1 plus or minus 4i over 3. So I have two complex roots here. They involve an I because I had a negative underneath the square root. So I can still solve those just like normal. We just need to understand that those are complex roots, and complex roots make the graph look a little weird. They don't actually cross the x-axis there. They're imaginary roots, so we can't see where they're actually crossing. They're imaginary. So I have two problems up here. I want you to pause the video, see if you can do these on your own, and then we'll come back and solve them in a minute. Okay, I've solved both of these, but there are a couple things I want to point out to you. When you factor this, you're going to get x minus 1 squared. When you take the square root of both sides, you have x minus 1 equals plus and minus 3. Now, it would be tempting to leave it like this. When we add the 1 over, you get 1 plus or minus 3. Don't do that. The only time you're allowed to leave a plus and minus in your equation like that is if something is underneath the square root. When you have this, that means x equals 1 plus 3 and x equals 1 minus 3. We can solve that further. That's x equals 4 and x equals negative 2. Don't leave it like this because there's something else mathematically you can do. You need your answers simplified, as simple as possible. In the next one, when you factor 4x squared minus 12x plus 9, you end up with 2x minus 3 squared equals negative 12. You take the square root of both sides. When I do that, this is an imaginary number. When I simplify that, I'm going to bring the I out, and I can also bring out a 2. So I've got the plus minus 2i square root of 3. Then I'm going to get the x by itself. When I do that, I end up with x equals 3 plus or minus 2i square root of 3 all over 2. This one, that's two complex roots, two imaginary roots. And there's nothing wrong with leaving it like that. When you've got something underneath the radical, you can leave it like this, no problem.